word problem. Our problem is Rachel's flight for Dallas takes off at 11:30 a.m. and is expected to land at 3:15 p.m. How long will Rachel's flight be up in the air? Okay, so the first thing I always want you to do whenever you get a word problem is go back and reread, and we're going to highlight the important information. So I see Rachel's flight for Dallas takes off at 11:30 a.m. So what I know about planes and my experience about planes, whenever a plane takes off, it means it is going really fast on the runway, and also it lifts up and it goes into the air. So I know when it says takes off at 11:30 a.m., that is my start time. So next to my start time, I'm going to write 11:30 a.m. I'm going to continue reading to see if I find my end time. So it goes, and is expected to land at 3:15 p.m. So whenever I see the word land in this word problem, that sticks out to me as a key factor in knowing it's my end time, because whenever a plane lands, it means it hits the ground, it's no longer in the air. So my end time for the problem is 3:15 p.m. So now what we're trying to solve is how long will Rachel's flight be up in the air? Another word for this, what we're trying to solve, is elapsed time. Elapsed time is the time between your start time and your end time. So in this case, it's how long Rachel's flight was up in the air. So how I'm going to model and demonstrate this word problem for you is through something I like to call linear model. Now, do you remember working on linear models? What's a linear model? Yes, you're correct. A linear model is a number line. So at the very bottom of the page, I'm going to draw a blank number line. Now you're going to see me make 3 marks, or ticks, whichever one you prefer to call them. My first mark is going to be my start time. So that is 11:30 a.m. My second mark that you'll see me make is I'm going to label on my number line where noon would be. So noon, we know, is 12 o'clock p.m. and is relatively close to 11:30, so that's why they're pretty close on the number line. You might ask, why do I label noon on the number line when it's not my word problem? The reason why it's good to always make sure that you label noon or midnight on your number line is because even though there's 24 hours in a day, on a clock, we only have 12. So it's a good way to have a base. And not only that, but it reminds you that you went from AM and now we're shifting into PM. So it's a good indicator and a good way to check to make sure that you always have your AMs and your PMs straight. And then my last and third mark is going to be 3:15 p.m. Okay, so the next step that you're going to see me do is called the Make 60 approach. This is very similar to whenever we were working with base 10 blocks and we were regrouping with base 10. I don't know if you remember correctly, we did this a couple of weeks ago. It's where we had, for example, 10 single units and we would have 1 rod. We would make the unit larger by saying 10 small units equals 1 rod, and that was called regrouping. However, with time units are grouped with 60 rather than 10. For example, we know that 60 seconds equals 1 minute. What else do we know about time? We know that 60 minutes equals 1 hour. So that is whenever I say make 60, what we're doing is I'm going to start at 11:30 a.m. and do my make 60 approach to find what it will take me to get to the next hour. So my next hour in this case is noon. I know it takes me 30 minutes to get from 11:30 to noon. So I'm going to label that 30 minutes. Now I am at noon, and then I'm going to skip count by hours to the hour nearest to my end time. This part's important. You're going to make sure you do not pass it. So I know from 12 o'clock to 3, I go from 12 to 1 o'clock to 2 o'clock to 3 o'clock. So now I'm going to count my hops. I'm going to skip count and go 1, 2, 3. So that right there, I know, is 3 hours. Okay, so lastly, we find the time left it will take to get to the end time. So from 3 o'clock to 3:15, how many minutes is that? I move right down my number line, 15 minutes. Now that we've got all of our minutes and hours, in order to find the elapsed time, we are going to add up our minutes and hours to get our product. A little tip that makes things easier is to add your minutes together and then go back and add your hours. So I know 30 plus 15 gives me 45 minutes. I see also on my linear model that she traveled 3 hours, so I'm going to say plus 3 hours. Gives me a total of 3 hours and 45 minutes. Rachel's flight was in the air. So that is how you solve linear model. Just to kind of go back and review as well, I know a common misconception that most students have whenever they are doing elapsed time is they either don't know really where to start, or they get their AMs and PMs confused, and not to mention when they start skip counting, they might do it mentally and they forget to add a couple minutes here, a couple hours there. It can get very confusing. So whenever you see a time problem, just go ahead and whip out your linear model and you will not get confused, or you should not have any misconceptions. But if you have any more questions, this is a perfect time to ask, and I'd be more than happy to answer them. But thank you today for your participation.